So today's lesson should be a fairly simple one. We are looking at symmetry, and so there's three different types. Right? And so this first one is line symmetry. This is the symmetry that we learned in elementary school. And so we looked at this triangle. It has line symmetry because if I draw in a line of symmetry down the middle here and I reflect the left side onto the right, it maps onto itself, right? And so like it says here, think of it as a mirror image. Point symmetry means that if I take this and I rotate it 180 degrees, then it will look the same upside down. And so I'm going to use this transparent paper here, right? And so if I trace this N, right, so here's the N, right? If I trace it there, this is the top, right? But when I rotate it 180 degrees, notice that it maps onto itself. It looks exactly the same, and so it has what we call point symmetry, because the point here, when I rotate 180 degrees, maps onto the point there, which gives it that same look. And then the last type is rotational symmetry, right? And so if we look at the sun here, right, again, if I'm gonna copy this. Oop, it's not the best. But with rotational symmetry, when I rotate it, right, it is going to map onto itself or look like the original if I rotate it less than 360 degrees. And so if you notice, right, as I rotate this thing, notice it's mapped onto itself here, right, and it maps onto itself again here, right, and it continues to map onto itself all the way around until I get back to the beginning right there. And so this one actually maps onto itself 8 times. Oops. Right, and so it has rotational symmetry. All right, again, it has to be less than 360 degrees. So now let's look at some examples, right? And so we want to determine if the figures have line, point, and or rotational symmetry. So they could have more than one. So if we look at this, hexagon, all right, notice right away, if I draw a line down the middle, we can actually draw it diagonally or across. That'll have line symmetry. If I were to rotate this, right, it would also have point symmetry and rotational. So if you want, you can always pause the video right now, and for number 2, for the triangle, try to think of all the different symmetries that it would have, and then once you have your answer, you can hit play again, right? So if you want to try it on your own, hit pause now. If not, I'm gonna answer it. And so again, if you look, it has line symmetry down the middle. If I rotate this though, the point's gonna be pointing down, so there's no point symmetry. And then this thing, if I rotate it, this point will go here, and then it'll go there all before we get back around. So it actually has rotational symmetry as well. The next one, number 3 here, this one actually doesn't have line symmetry. So notice if I draw a line down the middle, it doesn't match up. And then if I draw a diagonal line, they don't match up either, because this point will end up out in space over here, right? It ends up out here. So there's no line symmetry. But this one actually has point and rotational, because when I rotate it 180 degrees, that gives me point, and then rotating it also gives me rotational. And then the last one, this is a right scalene triangle, It does not have line symmetry. When I rotate this, it will not have point. And since I can't rotate it, it doesn't have rotational, and so this one has none. Right. You'll be able to print this worksheet out, use this worksheet to do the rest of the homework. Again, should hopefully be somewhat easy for you. If not, please ask me questions, email me, message me, or ask me tomorrow in class. See ya.